We're just getting used to delegates now. Hopefully you are. Remember the dynamic animator delegate that we set, and it told us when all the animation stopped, and then we blew up the blocks. Okay, so we just set a delegate of the animator to be the controller, and the controller implemented a method. Same thing here. You can set yourself as a delegate to this URL session, and as it's doing all its downloading, it'll give you updates. Oh, I loaded 5,000 bytes. I just loaded some more bytes. Oh, I've got the file now. Okay, I'm putting it into a file, a local disk. It'll tell you all these things. Usually you don't care about any of that. You just want it to tell you when you're done, which is what that completion handler is for. So here I'm going to set my delegate to nil. I don't even want to hear any of that mess. I just want my completion handler that you see here called. But the delegate queue, okay, tells you which queue are all your delegate methods going to be called on. Okay? And you can specify the main queue as we have here, or you could specify some other queue. Okay? You can even pass nil here and it'll just make up a queue for you, a random queue. So even though we're not doing delegate methods here, we are having that completion handler, and it calls your completion handler on the same queue as the delegates. So that's why that delegate queue line there is really important. What that says is call my completion handler, and all my delegate methods if I had them, call my completion handler on this queue. And I've specified the main queue. So that means the code that's inside my completion handler block down there, the part in yellow that says yes, can do UI things directly, that's being executed on the main queue. It gets put in line to run on the main queue, and when the main queue is quiet, it'll grab it and execute it. So I can do whatever I want UI-wise in here. I'm on the main queue. Now conversely, I wouldn't want to do anything expensive here, like look in the URL and parse it and build some huge data structure and all this stuff, something that might block the main queue, right, by taking a long time. I mean, it would have to really take a long time, but you know, or certainly wouldn't want to make another network call in that block, okay? But most importantly, I can make UI calls here. I could update, if this was an image URL, I could update my UI to show the image or whatever I wanted to do, because I've specified this is going to run in the main queue. Okay, question?
Does a queue finish a given task before swapping it out for something else?
The question is, does a queue finish a block that it takes out of the queue first before it grabs another one? Yes, if it's a serial queue, which is the kind of queues we're talking about. Yeah, it does them in order serially. Okay, so now let's look at a different case. What if we create an NSURL session that does not specify the delegate queue? So I just used NSURL session with configuration, no delegate or delegate queue argument there. This case does not use the main queue. It uses a different queue. Okay, there's no delegate, so there's no need to have the delegate method be specified. But the callback, okay, this completion handler gets executed on a different queue, not on the main queue, okay, because I haven't specified the main queue as the queue I want it to execute on. So in this case, if I want to do UI stuff, I have to make another block of stuff and put it onto the main queue. And I can do that either with dispatch async, dispatch get main queue, a block with the stuff, the UI stuff I want to do, or I can do self perform selector on main thread with some method on the main queue, or method that I want to execute, and it'll be called on the main queue. Okay, so do you see why I had to do that in this case? Because this completion handler is not being called on the main queue, it's being called on a different queue. So this is what you need to understand in iOS is when I have a block that's passed to some method, what queue is it going to be called on? Now most time when you pass a block to an iOS method, it's going to call it on the same queue that you called that method on. Whatever method you called and you handed it a block, it'll call you back on the same queue most of the time. But if the method, like this one, goes off and does something in another queue, then it's probably going to call you back in some other queue, unless you specify the main queue. Okay? Question?
Is the call dispatch async thread safe?
Is the call dispatch async thread safe? And the answer is yes, it is. And so you can use it for thread synchronization, actually, because it is thread safe. It's an atomic call. Okay? It happens atomically. It can't be interrupted by something else coming in and doing it. So that's a good question. Notice why the small thing, you notice I have task resume. You see that task resume? When you create a download task using this, it starts out suspended. In other words, not downloading. So you have to immediately resume it to start it. Okay, now that resume is going to start something happening in a different thread, not in the main thread, but still, task resume. Don't forget the task resume. Okay? Okay, that's it for multi-threading. I'm going to do it in the demo, so you'll get another look at it. You'll be doing it in your homework, so you'll get a feel for it. The idea here is just to get this idea of this main queue and these other queues, and then I have to post back to the main queue anytime I'm doing something on another queue. Okay, UI scroll view. So UI scroll view is a really important view. You know, the iPhone screen, anything that's going to fit in your pocket is going to have a small screen, but you might want to have it looking at a lot of information. Okay, and you want to easily navigate through that. Now I have this little video here. This is like from iOS 4 or something. That's why I left it with the, or it has the old background, the old kind of phone. But it's really good at showing what scroll view can do, because you can put any kind of view in a scroll view, including another scroll view. So you can see that I've got a scroll view that's scrolling horizontally, and the things in it are scrolling vertically. Okay, or here's a stock app where I'm scrolling horizontally through other scroll views that can scroll vertically inside of them. You see that? So I can present a lot of information here, not just the stock ticker value, but news about a stock, charts, etc. And I can just easily get at them by scrolling through. So scroll view is a really powerfully designed view that lets you put almost anything in the area it scrolls, including other scroll views. Okay? So let's look at how scroll view works. Scroll view is really just a view that you add subviews to, but it treats those subviews specially because it lets you scroll around on them and zoom in on them. So you know how to add a subview to a normal UI view, right? You just set the frame of the subview, you call add subview, bloop, it appears in the view. Easy. Even if you have a huge view and you say add subview, somewhere down there, but it gets added, but of course you can't see the whole view. Now you could shrink the view way down small, but then like this Stanford picture, you'd hardly even be able to see anything. Okay? So really what we want to do is be able to scroll around on these things. So how does this work, adding subviews to UI scroll view? Well, there's one really important thing. This is the take-home point on UI scroll view. You got to set its content size. So it has a property called content size, which is just a big size, and it makes the area that the scroll view is going to scroll around on. Okay? I made a big content size here, 3,000 by 2,000. Then, now when you add subview to the scroll view, it puts it in its content area essentially. So here I put this subview 1, which is the Stanford logo, 2,700 across, 100 down. You see that? And then let's put that big one in there somewhere. Okay, I put it 50 by 100 in there. And now what the scroll view is going to do is really kind of provide a window on that content area. So as the user scrolls around with their finger, it's essentially going to move around, showing you what's in that content area, right? Does that make sense? So that's all scrolling is, really, when it comes to the panning part of it. And you can position these views anywhere you want. So if I move this Stanford logo here, and then I move that huge thing to be the upper corner, maybe I change my content size to be smaller to include the views, okay? Now, again, I can scroll around, and you can see various parts. There's that Stanford logo. It's kind of overlapping the view here because those two views overlap in the content area, etc. So it's as simple as that. It's all about that content size thing. Now, as a programmer, you might want to know where is the user currently looking, okay, in my content area. And the way to get that is the scroll view property content offset. It tells you the X and Y of the upper left corner of the area that's being viewed. Okay, so that's an important part of it. The other thing you want to know is what's the bounds of the area the user is looking at. And some people have a little trouble understanding this, but it's very simple. That bounds is actually just the scroll view's bounds. Okay, the scroll view is a view. It has bounds, self.bounds, and that bounds is the area that's being looked at. Now, that bounds is in the content area's coordinate system, okay? And you might not want that. You might want to know in that image what is being looked at. And to do that, you simply convert those coordinates using this view method, convert rect to view. So you take those scroll view bounds, you convert rect to view, whatever subview in there, like the UI image view that's displaying that Stanford picture, and you could find out what it is in that view's coordinate system. Now, why would those be different? Well, okay, that Stanford thing happens to be up in the upper left corner at 0, 0, so it looks like it would be the same. But if that were not at 0, 0, then that would matter. Also, it could be zoomed. We'll talk about zooming in a second because scroll views can also zoom in. And so if you imagine if you were zoomed way in, looking in a window there, that the rectangle inside the Stanford view's view would be very small rectangle, right? Whereas in the scroll view, it's containing huge amounts. So that's why it makes it different what those two things are. Okay? So let's talk about how you create a scroll view. Very easy. You just drag it out from your storyboard. Okay? That's the number one way to create a scroll view. You can also do alloc init with frame. It's just a view like any other view, but usually you drag it out. It is possible to have a view sitting in your storyboard and do edit menu, embed in scroll view, just like you do embed in navigation controller. You know, maybe I don't understand exactly how that's supposed to work, but it seems to me like it doesn't do the right thing a lot of the time. For example, it seems to put like a little extra space around it. I'm not sure. I don't recommend embed in scroll view. I recommend just put your scroll view there and then add your subviews in code, okay? Or drag them in to a scroll view that's in your storyboard to put them in there, okay? But dragging them into your scroll view is kind of weird because your scroll view in the storyboard can only show you its visible area. It can't show you that huge content size. So I'm kind of a fan of put your scroll view subviews in code, okay? You put the scroll view itself in, drag and drop into your storyboard, but then put your things in code. I kind of recommend that. And the way you do that is just with add subview. Just set the frame you want for your view, which is in that content area coordinate system, and there's add subview. Simple as that. Don't forget to set that content size. That's the very first thing I talked about, and I'm talking about it again. If you don't set that content size, that big white area, the scroll view is going to be scrolling over nothing. It doesn't matter what views you've added a subview. That content size is what it scrolls over. It doesn't scroll over the views. The views just happen to be there if they're in the content size coordinate system, but it's that content size that's key. Don't forget to set that. And to reset it, if you're going to scroll over something that's changing size, it gets larger or smaller or whatever, reset that content size. Most of the scrolling around is the user with a touch gesture panning, but you can also scroll around using code. For example, scroll rect to visible. You specify a rectangle in the content area, and it will scroll that to make that rectangle visible. And you probably want it to be animated, so it slides over instead of just jumps, right? And there's a ton of other things you can control in a scroll view, which we're not going to talk about just for time constraints, but you can go look at UI scroll views documentation, things like whether scrolling is enabled at a given time, whether you can scroll horizontally or vertically or both. There's no scroll bars in iOS, but there are scroll indicators. You don't need scroll bars because you just scroll with your finger, right? You pan around with a touch gesture. But there are little things that flash on that kind of show you where you are in the content area. You can look at all that stuff in the documentation. All right, so now let's talk about zooming. Okay, so we've talked about panning around the scroll view. What if we want to zoom in on the content and zoom out? Remember that all UI views have this transform property. Okay, we used it to great effect in the animating world. And the transform lets you rotate and scale and translate a view arbitrarily. Okay, it's doing bits though, bitwise zooming. And UI scroll view takes advantage of that to do its zooming by changing the scale of the transform. Okay, so it scales the transform. So that means that your view, if it zoomed in a lot, could be kind of grainy unless your view doesn't know how to adjust itself once it's zoomed in. And we'll talk about that in a second. Zooming requires two very important things to be set. The first